So that's why, so when this type of error or arises systematically, when an error arises systematically, so it will call, okay. So the systematic error arises so we can remove this error by calculating this error, okay. So we can remove error by calculating error and subtract or from the reading, okay. Or add or subtract, or add, we can add, could be positive error or negative error. We'll come to this later, what is positive error and what is negative error. We can subtract or add, okay. We can add this error or subtract this, okay, and this error can be removed. On the other hand, random error may be due to random cause. For example, you measured this thing wrongly, right? It is your fault. So it is our fault, right? I can measure this thing what wrongly. Maybe due to sometimes maybe some disturbance due to air, due to vibration, right? This external effect could be there, right? So that's why this type of error may arises when you read something, okay, or when you measure something. So due to random causes, for example measurement or external effect, observer uh, uh, error, so error made by observer. So how can we minimize this error? How can we minimize this error? By taking repeated measurement and and take average so for your first measurement, it you got the value 1. Your second measurement you got the value x2. Your third measurement you got the value x3, and so on. For example, you made 10 number of such measurement, okay. Every time there may be some error, right? Measurement, okay. So what will be the accurate result? What will be the accurate result of this measurement? Accurate result you can say is equals to x1 plus x plus dot x10 divided by 10. Made 10 number of measurements like this. So in this case, how can we remove this? Let's say measurement shows this type of measurement, this type of error or delta x error. This could be either positive or negative, and your measurement is x. So what will be your accurate measurement? X minus delta. For example, accurate measurement and precise measurement. There are two types of measure: accurate measurement or precise measurement. To measure a length, in one measurement you can say 10 meter. First time you measured, it is 10 meter. Second time you measured, for example x1, it is 10 meter. Second time you measured, it is 10.1 meter. Third time you measured, it is 10.2 meter. Fourth time you measured, 10.3 meter. Fifth time you measured, 9.9 meter. Sixth time you measure, again 10.0 meter. Now you can see it is spread in a certain range. So it is not 10 point, you cannot say it is 10.0 meter. You cannot even say it is 10.1 meter. You cannot even say it is 9.8 meter or 9.9 meter or so. So every time you are very close to your measurement or accurate value, right? So this is called accurate measurement. It is very close to the actual value. So we will call this is actual measurement or accuracy. Not actual, it is accurate measurement. Not the actual value, but very close to the actual value. Now the same piece to measure, and you get value here 10.01 x2 equals to point here, point here, x4 is 9.98 here, 5. From these two measurement, we can easily say that this measurement somehow are very close, right? Very close to the actual value. Am I correct? So this is very close to the actual value. What is the difference? For example, average is its average should be what? On average karo 1 2 3 5 6 4 5 60.5 probably, right? Huh? Point, right? 10, right? And which is this is 10. It is almost 1.2 times per. What is the difference between these two result? 1 2 9 9. Sorry 08. Sorry. Right? From here to here, what is the difference? 02. One two, right? So this spread is large. So in this case, if we check this one, the value 50, right? Divided by 5, right? Now this spread, which is very close, right? This these are very close. The error is minimum here. You are very close to the accurate result. So that's why we can say more precise of your actual result, right? The error you received or got in second order, right? Not first order, second order. But in this case, get the error in first order term, right? So that's why this is more correct or more accurate than this one. That's why it is called size. Okay, result will be called size result. Actual, but not actual. Actual is maybe 10.0. Okay, so we can have precise result, and this is accurate. When the spread is large from the actual value, then it will be called. So what is the error? The actual value is equals to mean value, that I already mentioned. The actual value of your measurement will be mean value of your measurement. So for your first measurement, you got the value x1, for example 5.1. From second measurement, you got the value 5.2. From third measurement, you got the value 5.0. For 4, right? And we can say 4.9. So what will be your accurate value? The accurate value 5.1 plus 5.2 plus 5.0 plus 5.4 plus 4.9 divided by 5. 20, 24.6. 5.6. 5.6. Right now, so this will be your accurate value or mean of your measurement. Okay, so that's why when we do or we perform any experiment in laboratories, we actually take lots of measurement so that we can minimize our error. Okay, now what is the absolute error? So in this measurement, so this is your first measurement. So what will be your error here? It is the accurate value. Sorry, that is 5.12 minus 5.1 equals to 5 point, sorry, which is class error. Got the value here, right? Now in case 2, 5.12 minus 5.2, which is equals to minus, am I correct? In third case, 5.12 minus 5.0. Fourth case, minus, and in last case, right? Correct. Which is, so this will be the error got from this, right? So this is the accurate value minus your every time what is the value you observed, right? Now mean absolute error. What is the, so you can see your error is also spread, right? First time you got the error 0.2, second time you got the result minus 0.8, third time you got 0.12, fourth time minus 1.28, and fifth time minus plus 0.22. So what is the mean your error? What is the mean error, right? So whenever you take the error, so you cannot never subtract the error from any measurement. Every time you got the error, so error will add, always add. Every time you got some error, every time you got some error, every time you got some error, so error will going to add. Can never subtract. So in your life, lots of mistake. Never your mistake will going to subtract from the actual error, right? So how can we deal with that? So mean absolute error will be the magnitude of error divided by total number of times you take the mistake. So first time you got the plus error, second time you got the negative error, but whenever you take the error, you must take its magnitude. Magnitude means its value, not negative sign. You cannot subtract the error from the result. It will always be there. Your error always be there. Okay, it will not minimize your error. So you first time you take error in positive direction, second time negative direction, subtract from your error. So this will be called mean error. So you got the error from first one is delta x1, second delta x2, third delta x3, and so on. For n number of times we got the error. So from this previous calculation, we can say your average error delta x here equals to 0.2, 0.2 plus 0.8 minus eta minus 2 plus 0.2 plus minus plus 5, right? So gives you 2 plus 0.08 plus, this is minus, okay, plus 0.12 plus 0.8 plus equals to 0. Divided by 5, which is equals to 1, around 1, right? This will be your, this could be positive error or negative error. Sometimes this error will be positive or sometimes will be negative. But if it is negative, then every time you have to take that negative error, you have to add this negative error. So once you add this negative, you cannot take negative error, and next measurement you cannot take positive error, and third measurement you cannot take positive error. So it is a fixed error. You have to take the absolute, and then it will be plus minus error take plus or minus. The instrument can show the positive error or it can show the negative. How? Question is how we are going to answer this question. Because vernier calipers and slide calipers. Why positive error and why negative? Okay, clear? So your result, so your accurate result or your observed result will be what? Accurate value plus your, okay, with sign. So your accurate value representation means your observed result or your reading. Okay, so this is observed result. Equals to x equals to accurate, mean accurate, right? Accurate or mean as your yes. And finally, okay, how can you take the percentage? So for measuring x, how much error we have made, okay, so we'll take that and we'll write by x. Okay, for example, for example, so this is an you can rectangle of length L and with say B. So you made some error calculating L is delta L, and in this case delta B. So what will be the error for this one? So it will be fractional, it will be delta L by del. For delta L, made this error, na? So what will be the fractional error? It will be delta L by L. For this one, made error delta B. So the fractional error for this one will delta B. Okay, and you can take the percentage of this. So that will give you the percentage of error. So if you take or multiply by 100, it will gives you the percentage of. Okay, if we take percentage of this or multiply by 100, it will gives you percentage. Okay, so in your measurement, some measurement you made some error delta x for calculating what? Accurate value or absolute value, right? So you made this mean error for calculating accurate value, right? So what will be your fractional error? Your error or mean error divided by your accurate value, and when you take the percentage, you will multiply by 100. So representation again, what is the representation? So your value plus percentage. For example, your result in terms of percentage. So it is not in terms of percentage, in terms of error. So these measurement is in terms of error, not percentile error. So you can take the value in terms of percentile error also. What percentage of error you made the experiment? So then you will calculate the percentile error, right? Then you add with your result or accurate value. Okay. For example, for example, for calculating length of 10 meter. Okay. So your main value gives you what? How much? 10 meter. 10 meter. Some experiment. And you made some error for delta x is equals to 0.02 meter, right? So what will be the fractional error? Fractional error which is equals to 0.02 divided by 10 equals to 0.002. So what will be your error or your value? You can say the observed value, which is 10 plus minus, or in terms of percentage, so we will multiply this by 100. So this is observed value in terms of percentage. So x will be x bar plus minus percentage, so which is equals to 10 plus minus 0.002 into, right, plus minus point percent, right. This will be your, or will be your প্রবলেম যখন সলভ করব থিওরি দিয়ে কিছুই যায় না, অলমোস্ট প্রবলেম যখন সলভ করব অনেক ক্লিয়ার। proportionate error. So for example, in your measurement you want to add this volume with this, and you got some new volume, right. So this is a B1, this is a B2, and you'll have B1 plus B2. In measuring B1 you got the error B1, measuring B2 got some error B2, right. So what will be the, what will be the error here, what will be the actual value? So actual or your measurement will be V equals to 1 plus delta V plus V2, okay, equals to V1 plus V2 plus this could be either plus or minus. So in that case we will take plus minus. This could be either plus or minus, then it will be either plus or minus. But the net will be here either plus or minus. But these with these two will always add. Error will always add. You may subtract these, right? So you have something and you subtract some volume at the same time. You have some volume, initial volume, say V1, to subtract some amount from here, say this amount, okay. Now your volume remains what, this much. So this will be, so this is V1 and this must be equals to what? So V must be equals to V2 minus V1, but you got the same result, plus minus delta V. Here you got the error here, delta 1 plus minus. So what will be your new volume? This, or better way to write, V2 plus minus delta V minus V1 plus minus, which is equals to V2 minus V1 plus minus delta V2 plus always. So your error will be here plus minus, but total error always, no matter you add some or you, okay, no matter, okay, yeah. So always error will add. So no such case where you can minus, or for multiple number of measurement you cannot, not going to remove error, you are going to remove from the measurement, you will never going to remove from the, okay. Multiplication, if the number or the your variable is the form of multiplication. For example, y equals to x into y. This could be your form. For example, area, right? You take a sheet and you're calculating this area. So this is x. What will be its area? Oh, this is z. This is not y. So what is area? You can take area is equals to x y. So in this case error for delta x, you made some error for delta x measuring a, made delta x amount of error. For y, delta y. So we will take the fractional error, and error will always. So fractional error, what will be the fractional error? For x1 is delta x by x, for y delta y by y, and for calculating this z will be plus minus delta z always equals to delta x or delta z. এখান থেকে better বলাটা ভালো, not delta z by z, or your fractional amount will be always delta x by x plus delta y plus this will always. So this will be the total amount, and for your measurement this will be your, will add plus minus delta z. Your actual value you can take here the plus minus, okay, not here, not in this equation, okay, your value plus your error. So this is your fractional error. So in your value or measurement you will add this or subtract this, okay, not here, okay. এটা যদি এরকম হতো y equals to ab cube, yes. So in this case we will take delta y by y is equals to delta a by a, but what about b? Will take b front of this equation, delta b. অনেক বেশি ক্লিয়ার হবে যখন আমরা ডেরিভেটিভ শিখবো, ডেরিভেটিভ রুলস ইউজ করব, দেন ইট উইল মোর ক্লিয়ার, okay. So when we apply calculus, this equation will be, and we will use logarithm, okay. So this will be the rule, you can say this is the rule, okay. So for example, z equals to x to the power p, y to the power q, then general rule delta z by z gives you delta x by x plus q delta y. Now for the same result you got a constant, some constant to the power p, y to the power q. For a constant quantity there will be no error, okay. For constant quantity there will be no error. So in this case it will always be p delta x by x plus এটা 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 y করে দিন, বেটার হবে। Okay. So there will be no error for, we will not going to calculate error for constant, it is constant. For any constant they have no error. For example, so z equals to 6 x square plus yes, what will be the error or fractional error? What will be the fractional error in this case? Delta z by z for constant. So this is a number, no? Number is constant. Cannot take for this 6. Okay, so this will gives you 2 delta x by x plus for 9 you cannot take any error, delta x by x plus delta y. And someone asks for percentage of error, you will take the percentage or you can multiply both side by 100, right? So you can take the percentage error, percentage, right? Okay. Multiplication. What about division? What about division? For example, your z equals to a divided by b. What happened then? Delta z by z equals to delta a by a. Error is always this also, or z equals to the power p divided by y to the power q, then z equals to delta x by x plus q del y by. Confusion? Any confusion? Sharmishta? Confusion? বলতে পারো, রিপিট করবো। ওকে, and for percent, ও ভুল করেছি, obviously for percentage find the fraction of error করে ফেলো। a square b cube by c cube, square b cube by c cube, square b cube by c cube, c to the 4, c to the 4, to the 4, delta y by y 2 delta a by a plus delta b by b plus and for percentage will multiply by 100. Find the area in proper limit. Given proper limits means with find the area proper limits means with error. So in calculating or measuring L, you have error, find error this, measuring B to find error this. So what will be the error measuring area? You have to find out the error in measuring area and then you will add that or subtract that error from your actual area, right? What is your actual area? First my question, huh? Okay, 8 meters. Excellent. How? Excellent. So area is nothing but L into B. So L is the actual, you can say, measurement, which is equals to 4 into 2, that is equals to 8 meters. Again, we know delta A by A is equals to what? Delta L by L plus delta B by B. Can we calculate delta L by L, which is equals to what? 0.04 divided by 4, which is equals to 0.01. Again, delta B by B, 0.02 divided by 2, which equals to 0.01, right? Then total amount of area, so delta A by A is equals to 0.01 plus 0.01. Excellent, which is equals to 0.02. Can we calculate delta A, which is equals to 0.02 what? A. Am I correct? A, right? Which is equals to 0.02 to 8 equals to 0. So what is your area? Area A is equal to 8 plus minus point. Here, yeah. Or was the problem? So first of all, calculated the area without error. So this should be our area, but we made some mistake. And what amount of error we made? We calculated from this relationship, right? Then we calculated the error. This is fractional error. This is not the error, right? So this is a fractional error. We from equation we calculate the error, add or subtract what observed value. Okay, এটা করো। So x তোমরা দেখতে পাচ্ছ x is given a square b by c to the power 1/3 power or 1/3 d to the power 3. So what is the percentage error. Find the percentage error in measurement of x. Just now calculate. So what is x is equals to square b e to the power half cube delta x by x, nothing but a by a up to 1/3 এটা, হ্যাঁ sorry, right? Given delta percentage is equals to 1%, 1% plus percent in b plus 1/3 of 3% of c plus 4% of d, right, equals to 2 plus 2 plus 1 plus percent. Okay, বেশ এটুকুনি থাক পার্সেন্টেজ অ্যান্ড এরার ক্যালকুলেশন প্র্যাকটিস করব, মোর ক্লিয়ার হবে। তো প্রচুর থিওরি পড়লে খুব একটা হবে না, যত বেশি প্র্যাকটিস করতে ব্যাপারটা থাক। But কোথায় কোথায় এরার হচ্ছে, তবে এরা আসছে, ওকে। ধরনের ইনস্ট্রুমেন্ট, মেনলি দুটো ইনস্ট্রুমেন্ট নিয়ে তোমাদের রয়েছে সিলেবাসে, ওয়ান ইজ স্লাইড ক্যালিপার্স or ভার্নিয়ার ক্যালিপার্স, স্লাইড ক্যালিপার্স or ভার্নিয়ার ক্যালিপার্স, অ্যান্ড স্লাইড ক্যালিপার্সটা আজকে আমি একটু দেখাবো, অ্যান্ড মেজারমেন্ট কি আমি দেখাবো। টু গেজটা নেই, বাট এর একটা ডামি রয়েছে, ডামি ভার্সন, টুয়েলভটা নেই, ডামি দিয়ে বের হয়ে যাবে। তো ফার্স্ট অফ অল মেজারমেন্ট অফ লেন্থ ইউজ করি নর্মাল স্কেল or মিটার স্কেল, can say centimeter scale, normally 10 centimeter or 1 meter, right? These are called meter scale or centimeter. From this meter scale or centimeter scale, what is the minimum length we can measure correctly if it is not a faulty, right? It is 1 millimeter. So here it is 1 millimeter, 1 millimeter, 1 millimeter, 1 millimeter, 1 millimeter, 5 millimeter, 1 millimeter, 1 millimeter. Each division gives you 1 millimeter, and this 10 division gives you 10 division is equals to 10 millimeter or 1 cent. What will the measurement? For measurement z equals to y minus x, you can say signs, right? So this could be like from, it can start from here, end here, right? So this is y. Yes. So you will calculate, or you will find where it is touched, end touched, and your tail touched, sorry, tail or beginning or end. So this will be your measurement. So in this case, what will be your measurement? Z equals to 3 minus 1. It is in centimeter scale. So what is the least count of this scale? 1 millimeter. It is the minimum measurement which you can measure from this scale, called the least count or minimum count. Okay. So each division will be its count. Okay. So you can see from this scale you can measure only up to 1 millimeter or 0.1 centimeter. How can we increase? That means we can accurately or more accurately measure someone's length or diameter or etc. Right? So we will use vernier caliper, okay, or slide caliper, like this. There are two scales are there. One is called, this one is called main scale, and this scale. So scale here you can see this dot line called vernier. Okay. So these can rotate, okay, or this can slide. So by help of this screw you can slide one over another, right? One over. And you placed anything, and calculate thickness, right? You can calculate its out. First of all, we'll see where the vernier actually meet the main scale, or is slightly right of the main. Okay, where it is coincide with the main scale, or just slightly right of the main. So the main scale which is just below the vernier scale or first vernier reading. So first vernier is this one, right? Which is just below the first vernier will be the main scale reading. It may exactly match with the vernier scale or may show some gap. Okay, so here it may show some gap or it may may also touch the vernier. So in this case, you can see the vernier did not touch the main scale. This one is vernier scale and it is main scale. You will find where which mark just below the vernier scale, which marks in main scale, which mark main scale is just below the vernier scale. So that will be the reading of main scale. Can you say what is the main scale reading? One reading. The main scale which is just below the vernier. Vernier, which one is vernier? The top one is vernier. Which one is vernier? In main scale, which reading is just below the vernier? First vernier or first mark in vernier scale. চলে আসে আমার কাছে চলে we always observe normally. Okay, always observe. Will just touch or just below the vernier. Okay, it will just touch or just below the vernier. One which is just touched or below the vernier. Vernier means vernier first vernier যেখানে start হয়েছে এর below তে কে আছে? One. One. One it is. Now, but if you observe carefully, the vernier scale and main scale not shading condition. They did not match, right? Slightly deflect, right? How can we measure this amount? This will be also a value, na? This will also have some value. Am I correct? They are not in match. There is a slight difference, right? One is just above the main scale or a forward in a forward direction, right? So we got in main scale it is 1 centimeter, right? So or 1 point something or 1 point delta x, right? So this is your main scale reading and this is something, right? Some value. Now we have to find out this value, right? We will find this value from what? Vernier scale. Find this value from vernier scale. Now it is very much clear it is not 1.1. Again, it is not 1.1. The main scale, the vernier first vernier did not touch the 1.1 reading also. So it is in between 1 and 1.1. Can easily it is in between 1 and 1.1. So that in between value will calculate from vernier scale. Question is how. For main scale reading, we need to know the least count. At the same time, for vernier reading, you have to find out the least count. Okay. Now, for vernier, we will going to calculate the least count. What is the least count or minimum count or minimum value we can measure from the vernier scale? Here, what is the minimum value we can calculate the vernier scale? Now, the principle is that n vernier scale division is equals to n minus 1 main scale. Principle is that for vernier calipers, n vernier scale division is equals to n minus 1 main scale division. That means 10 vernier scale division we can write 10 minus 1, which is equals to 9 main scale division. Correct? Now, 1 main scale division is equals to what? 1 millimeter. Then 1 main scale division is equals to 1, right? Here, least count of vernier scale can be defined as the least count of a vernier calipers can be defined as least count equals to 1 main scale division minus 1 vernier scale division. 1 main scale division minus 1 vernier scale. Now, what is the value of 1 main scale division? 1 millimeter. What is the value of 1 vernier scale division? 9 vernier scale division gives you 10 vernier scale division. Can we write is equal to 10 9 millimeter? Can we write? Can we write it? 1 vernier scale division. Can we write 9 by 10? 2.9. Write it. Write it. Which is 1 main scale division 1 millimeter, 1 vernier scale division 0.9 millimeter, which is gives millimeter. So what is the least count of vernier scale? 0.1 millimeter. But what is the centimeter scale or your meter scale reading least count? Was 1 millimeter. Now can get the value up to 2.1 millimeter. Here again this least count you can also calculate this way: 1 main scale division divided by total number of vernier division. Total number of vernier. 1 main scale division divided by total number of vernier division. So 1 main scale division is 1 millimeter. What is the total number of vernier division? 10 here. Or in this case 10. Okay. So yes, it is this. What the vernier scale? The vernier scale which has 10 20 division will 1 by 20. A vernier scale which has 20 division, it will be 1 by 20. Am I correct? It will be 1 by 20. Right? Okay. So this is our least count. And what will be our measurement value? Right? So the measurement value, the main scale reading. So we'll note the main scale reading first. We'll calculate the vernier scale division or measure, or we'll find the vernier scale division which actually match the main scale. Does not matter in which main scale. You have to find out that vernier, the line of that vernier which actually uh, touch the main scale. Okay, you have to find out that line of the vernier which actually coincides with the, no matter which one in main scale. Just you have to find out the vernier mark which actually coincides with the main scale. Let me again check. I have find something. Now you find. So you have to find out the vernier mark which coincides with the main scale. Perpendicularly, observe perpendicularly, normally. Otherwise there will be an error. বুঝতে পারছো না? কাছে চলে ভার্নিয়ার স্কেল কোনটা? এটা, এটা। এই এই যে মার্কগুলো রয়েছে মেন স্কেলে কার সাথে ম্যাচ করেছে, কোইনসাইড করেছে? দেখো কোথায় করেছে, কোথায় করেছে? কত নম্বর ভার্নিয়ারে কত নম্বর ডিভিশনটা মেন স্কেলের সাথে কোইনসাইড? 0 না। মেন স্কেলে কোথায় টাচ করেছে? ভার্নিয়ারের কোন ডিভিশনটা? ভার্নিয়ারের ডিভিশনটা মানে ওয়ানে কি হলো আমার দেখার দরকার নেই। আমি দেখবো ভার্নিয়ারের এক্স্যাক্টলি কোন ডিভিশনটা মেন স্কেলের সাথে ম্যাচ করে। কত ঠিক করে দেখো, দেখো তো 3 এর সাথে ম্যাচ করেছে কিনা দেখো তো ঠিক। ভার্নিয়ারের 3 নরমালি দেখবো, এভাবে নরমালি দেখবো, এইভাবে নরমালি দেখবো, এর সাথে এটা প্যারালাল কোইনসাইড করেছে মানে সেম লাইনে থাকবে, তাই না? কোইনসাইড করেছে মানে দুটো কি সেম লাইনে থাকবে। এটা নরমালি দেখবো, দেখবো কোথায় সেম লাইনে আছে, দুটো লাইন কোথায় সেম লাইনে আছে। দেখো লাইন কোথায় সেম লাইনে আছে, একটাই লাইন মনে হচ্ছে, লাইনকে একটাই লাইন মনে হচ্ছে। ভার্নিয়ারে দেখবে, মেন দেখার দরকার নেই। ভার্নিয়ারে কোন লাইনটা মনে হচ্ছে মেন স্কেলের সাথে একটাই লাইন। 1 পয়েন্ট কোথায়? এটা তো 0, এটা তো 0 ভার্নিয়ারে, এটা 1, এটা 2, 3, 4, 5, 6, 5। নরমালি দেখো, নরমালি ভার্টিক্যালি দেখো, এইভাবে ভার্টিক্যালি দেখো, ভার্টিক্যালি দেখো, এইভাবে দেখলে হবে, ভার্টিক্যালি দেখো, সব টু ফাইন্ড ইট ভার্টিক্যালি। থ্রি, ও বলছে 3, কেউ তুমি কি বলছো দেখো তো? বুঝতে পেরেছো? ভার্নিয়ারের এই যে মার্কগুলো আছে মেন স্কেলের সাথে কার সাথে মনে হচ্ছে যেন সেম লাইনে রয়েছে, তাই তো? তো ভার্নিয়ারের ওই মার্কটাকেই আমি কি করব, আইডেন্টিফাই করব। ভার্নিয়ারের কোন মার্কটাকে আইডেন্টিফাই করব? যেটা মনে হবে মেন স্কেলের সাথে স্ট্রেট লাইন, স্ট্রেট লাইন। ওর মনে হবে 2, ওর মনে হবে 3, কারো মনে হবে 4, তার মানে কিছু না কিছু এরর থাকবে। তাহলে একে মিনিমাম কি করে করব? নাম্বার অফ মেজারমেন্ট, তাই তো? মিন হয়ে যাবে, কোনো একটা বার 3 আসবে, কোনো একটা বার 4। সবসময় এটা নর্মালি নেওয়ার কথা, নর্মালি আসবে সবসময়, স্লাইটলি বেঁকে থাকতে পারে। তো এই এরর গুলোকে কি বলবো? র্যান্ডম এরর, তাই না? র্যান্ডমনেসের জন্য এটা এইভাবে নর্মালি থাকার কথা ছিল, মানে সরে গেল। এটা অবজারভেশন এরর ইউ ক্যান সে। তো দিস উইল বি কল্ড র্যান্ডম এরর। র্যান্ডম এররকে মিনিমাইজ কি করে করব? ম্যাক্সিমাম মেজারমেন্ট নেবো, আর ইনস্ট্রুমেন্টেরও কি থাকবে, এরর থাকবে, সেটা আমি জানি। তাহলে ও বলছে যে মেন স্কেল রিডিং আমি পেয়ে গেছিলাম, তোমরা সবাই এগ্রি করেছিলে আমার সাথে। তাহলে আচ্ছা, লেন্থ অফ দা কি হবে, রড কি হবে? এই যে এই অবধি কি করেছে, অলমোস্ট ম্যাচ করেছে, অলমোস্ট ম্যাচ করেছে ভার্নিয়ারের। সরি সরি সরি, এই তো এটা ভার্নিয়ার স্টার্ট হয়েছে, এখানে ম্যাচ করেনি, একটু সরে গেছে, জাস্ট বিলো। আমরা তাহলে কোন রিডিংটা নেবো? জাস্ট বিলো দা ভার্নিয়ার। তাহলে এখানে দেখো 1.1, 2, 3, 4, 5, তাই তো? এখানে অ্যাকর্ডিং টু দিস is 1.5 সেন্টিমিটার, রাইট? তো দিস ইজ সেন্টিমিটার না, 1, 2, 3, 4, 5 পয়েন্ট নিয়েছি, তাই ওটা সেন্টিমিটার হয়ে গেছে। এবার মেন স্কেলে দেখো এই পয়েন্টে এসে কোইনসাইড করেছে, দেখতে পাচ্ছ, তাই না? তাহলে কি মেন স্কেল, ভার্নিয়ার আর মেন স্কেল কোথায় কোইনসাইড করেছে? এই পয়েন্টও নিতে পারো, এই পয়েন্টও নিতে পারো, আমরা এটাই নিচ্ছি, অলমোস্ট দুটোই। এখানে দেখতে, এখানে দেখলে ক্লিয়ার হয়ে যাবে প্র্যাকটিক্যালি দেখি। তাহলে আমরা এই পয়েন্টটা নিতে পারি। তাহলে কি এটা কত হবে? ভার্নিয়ার কোন ডিভিশন? 1, 2, 4, 5, তাই তো? তাহলে ভার্নিয়ারে কোন ডিভিশন হচ্ছে হলো, তাহলে ভার্নিয়ার স্কেল ডিভিশন ক্যালকুলেট করে নিলাম, which is 5 here। তাহলে ভার্নিয়ারের রিডিং কি হবে, ভার্নিয়ার স্কেল রিডিং is 5 division to least count. So this is nothing but you can write vernier scale, okay, so it will gives you 5 into 0.01 0.01 মিলিমিটার ছিল, দেখো 0.01 সেন্টিমিটার, তাহলে এটা কি হবে 0.05, তাহলে রিডিং কি হবে, মেজারমেন্ট কি হবে, রিডিং উইল বি 1.5 প্লাস 0.05, পারলাম, কনফিউশন। তাহলে ফার্স্ট অফ অল দেখবো যে কোথায় টাচ করেছে অর জাস্ট বিলো দা ভার্নিয়ার স্কেল, ওকে। তাহলে যা এই লাইনটা কি আছে বলতে পারি, জাস্ট বিলো দা ভার্নিয়ার স্কেল, তাহলে এটাই হয়ে যাবে কি মেন স্কেলের রিডিং। মেন স্কেলের রিডিং আমি পেয়ে গেছি, আমার কোনো প্রবলেম নেই। এবার আমি কি অবজার্ভ করব, এই ভার্নিয়ারের যে রিডিংটা আছে আমার এইটুকু এক্সট্রার জন্য তো রিডিং করতে হবে, রিডিং পেতে হবে, সেটা কোথা থেকে পাবো, ভার্নিয়ার থেকে। কি মেজার করব, উইল অবজার্ভ দ্যাট হুইচ ভার্নিয়ার ডিভিশন actually coincide with the main scale division, okay, which vernier scale division coincide with the main scale division. So we can see here, right, vernier scale division coincide with the main scale division. So we calculate or take the vernier scale division, multiply by least count, gives you the vernier scale reading. Your reading will be main scale reading plus vernier. Calculate this one, problem. হ্যাঁ, আমি বলে দিই প্রবলেমটা, দেখিয়ে দিই, পেরেছো না পারোনি, পারছো, you sure? So here given, while measuring the diameter of a sphere with a vernier calipers, main scale reading and vernier scale reading at the main scale reading পেয়ে গেছো 35 millimeter and vernier scale reading is 5. 5 means 5 division, right? 5 means here 5 division. Vernier scale division is here 5. What is the least count of vernier scale? What is the least count of this vernier scale particularly? For this vernier scale, why? It has 20 division, 19. So least count is equals to what? 1 main scale division divided by number of vernier division, which is equals to 2, because 20 if vernier scale coinciding with 19 division. Which vernier coinciding with 90 division? 20, because it was n minus 1. N minus 1 vernier will always coincide with, sorry, n vernier coincide with n minus 1 main scale. So n minus 1 is 19. What is the number of vernier division? 20. So this is 20 equals to 1 meter divided by 20 equals to 0.005. Correct? Millimeter, right? 0.05 millimeter. You did not got that. Now, here it is given if the vernier scale coinciding with 90 division. So what is the principle? N vernier scale division is equals to what? N minus 1 main scale division. It is given main scale division is 20. What is the vernier scale division then? Main scale division it is 19. What is vernier scale division? Main scale division is given. Main scale division is 19. If the vernier scale coinciding with 19 division of main scale, right? 19 division of main scale. What is the vernier division? One main scale division gives you the value because it is in meter, millimeter. Is in millimeter. So one gives you 1 millimeter. One division gives you 1 millimeter divided by 20. Right? So this will gives you 0.05 millimeter. So what is vernier scale reading? 5 into 0.05. What is the reading? Right? Okay. Scale error. দেখো এই দুটোকে যখন টাচ করিয়েছি, touch this. Now you can see the vernier scale and main scale are 0 of vernier scale and 0 of main scale coinciding. So we can say in this case 0 of main scale is coinciding with 0 of vernier scale. So in this case we have 0 0 error. 0 0 error means this error is called 0 error. The error is called 0 error. Now your error is 0. So that's why it is called 0 0 error. Your 0 error equals to 0. In this case, here you can see that vernier is ahead of main scale. So you did not measure anything, but you got some value. Measure anything, got some value. What is that? How much value already you have in your hand without any measurement, right? So this error will be called positive. Positive. Okay. And if it is below the 0 line of main scale, if the vernier is below the main scale, it will call negative. Okay. If it ahead of vernier scale, main scale, if the vernier is ahead of main scale, called positive 0 error. It is below the vernier scale, it is called. How can we calculate this 0 error? Now in this situation we'll observe which one coinciding with main scale. In this case 6 coincide with main scale. So this 6 division actually producing error up to, right? So what is the error here in this case? Least count into vernier scale division. Am I correct? So which is equals to 0.1 millimeter to 6. Let us assume it is this count is 0.1. Assume. Okay. So this 0 error equals to 0.mm. Okay. And this is positive 0 error. That's why we will take positive here. If it is positive 0 error, we will take positive. In this case, again it is coinciding with 6. So in this case also 6 into what? 0.1 millimeter. This will gives you minus 0.6 of negative error. So what will be your actual reading? So actual reading equals to observed reading as 0 with sign, with Sign means if it is positive 0 error, you will put the value +6. If it is negative 0 error, put -6 within bracket. Negative negative will give you positive. Okay. Okay. So for positive 0 error, it will be, so reading equals to observed reading, actual reading বলবো, minus positive for positive 0 error, and for actual reading minus, sorry, okay, here understood করো এই থাকো করে। আজকে এই চ্যাপ্টারটা কমপ্লিট করে নেক্সট দিন শুধু একটা প্রবলেমস করবো, এনসিইআরটি প্রবলেমস থাকবে, প্রবলেমস থাকবে, আইডি প্রবলেম। ফার্স্ট ডে আমরা প্রবলেমস করবো, 20 নাম্বার প্রবলেম করবো, বাকি প্রবলেমসগুলো বাড়িতে বসে বসে প্র্যাকটিস করবে, যে প্রবলেমসগুলো আটকাবে আমরা একটা ক্লাস মেবি ফার্স্ট ডেতে প্রবলেম নিয়ে উইদিন নেক্সট ফার্স্ট ডে প্রবলেমগুলো কমপ্লিট করবে মানডের মধ্যে। আজকে মানডে, উইদিন নেক্সট মানডে প্রবলেমগুলো কমপ্লিট করা কতগুলো প্রবলেম হয় মেনলি এনসিইআরটি আর দেন your NEET and can start এসি বামাটা ফর নাও এসএলআর আর কি আর হয়েছে নতুন যার কাছে যেটা থাকবে স্টার্ট করে দাও, আর পিডিএফ পাঠিয়েছি অলরেডি, কোনো একটা বুক স্টার্ট করে দাও। এখন যদি প্রবলেম স্টার্ট করো না করো, অনেক প্রবলেম সেখান থেকে পারবে না। ফার্স্ট অফ অল বলে রাখি, কিটসগুলো সম্বন্ধে ধারণা নেই, পাজেলড হবে না, এমন কিছু ভাববে না যে এটা মানে আমি জানি না, আমার পারবো না, প্রবলেম হচ্ছে। ফার্স্ট চ্যাপ্টারে প্রচন্ড প্রবলেমস হবে, রাইট? পরে এই প্রবলেমগুলো থাকবে না, কারণ অনেক কিছু ডান। হ্যাঁ, গুড, বলো লিস্ট কাউন্ট 0.1 হোয়াট প্লাস 0.3 মিটার। Vernier calipers has main scale graduated in millimeter, right? main scale in millimeter. So one division, so one main scale division equals to, we can take 1 millimeter, right? There is 10 division in vernier scale, 9 equals to 9 in main scale. So what is least count? 1 main scale division divided by number of vernier scale division, number of vernier scale division, 1 millimeter divided by 10 equals to 1, 1. And now when the two jaws are in contact, that means two jaws are in contact, the vernier scale the zero of the vernier scale is ahead of 0. Ahead of 0 means positive error, right? Positive 0 error means it's third division. Yes, it is third division. So what is error? Equals to vernier scale division count. Here it is third. Point. Now এখানে যদি বলে দিত মেন স্কেল রিডিং তাহলে কি করতাম? ক্যালকুলেট করতাম, উইথ এরারও ক্যালকুলেট করতে পারতাম। অলরেডি এরার ক্যালকুলেট করে নিয়েছি, মেন স্কেলের রিডিং বলে দিত, ভার্নিয়ার স্কেলের রিডিং বলে দিত, তাই তো? তাহলে কি করতাম? উইথ এরার উই ক্যান ক্যালকুলেট দ্য রিডিং। সেম থিং গেজ, টু গেজে আরেকটু বেটার প্রিসিশনে মেজার আপ টু 0.001 which is equals to 0.01। ভার্নিয়ার ক্যালিপার্সে কত ছিল? 0.1। এখানে আরো ফাইন মেজারমেন্টের জন্য, ফাইন যদি যদি কোনো ওয়্যারের ডায়ামিটার ক্যালকুলেট করতে হয়, or your diameter of your hair, so this type of measurement you calculate from your screw gauge. So in screw gauge, one is main scale or linear scale, another is circular scale. So this is called main scale and another is circular scale. The scale which is in circularly marked in this rotating frame called circular scale. On the other hand, the marks is on the axis of this diameter, or you can say this scale, it's called main scale. So these can change like this. If you rotate it clockwise, it will move leftward, and if you rotate it anti-clockwise, it is rotating. Okay, so you can place something like this, very small object, you can rotate, and after some time it will fixed some point. Now you will find the main scale reading from main scale, and you will find a point which will coincide with circular scale. From that coinciding with circular scale, you will find the circular scale reading, and you will see which main scale is which main scale it is setting. So that will give you the main scale, or slightly the main scale will give slightly gap. The minimum main scale you can actually observe. The rest part will be inside this. The rest part will be inside this one. When you will circulate this one, this will move in this direction. Now in this case, you can see this division only, right? This division only. You can observe this. So this is 1, 2, 3, 4, 5, and after that 6 is not observable. So your main scale reading will be 5. It could be 1 millimeter. Each division could be 1 millimeter, or it could be 0.5 millimeter, depending on the scale. Okay, could be 1 millimeter. Each division could be 1 millimeter or 0.5 millimeter. So up to which you can calculate 5. So let us assume in this case it is 5 millimeter, right? Now you can see there is a gap. After that there is a gap. Now in this scale you can say it coincides with 13, right? Coinciding means main scale, the 13 division of circular scale coinciding with main scale or the axis. This is called, this line is called axis. Okay, so your vernier scale, or sorry, circular scale division is equals to, in this case, say 13, right? Now in this case also you have to find out least count. Least count, now then you can calculate the circular scale reading. Circular scale reading will be circular scale division, correct? What is least count in this case? Very easy. Now when you rotate it also, when you rotate this one, the axis actually moving, so this axis travel a linear distance. For one complete rotation, the distance traveled by this main scale, but for one complete rotation, for one complete rotation, for one complete rotation, the distance traveled by the main scale called pitch. তার মানে তুমি এখানে ফার্স্ট অফ অল এই পয়েন্টে 0 তে সেট করে রেখেছো, তাই তো? এগেইন ঘোরাচ্ছ, এটাকে ঘোরাচ্ছ 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 ঘোরাচ্ছ, এগেইন আবার কোথায় এলো? 0 তে এলো। তাহলে মেন স্কেলে কত ডিসটেন্স ট্রাভেল করো? It gives you the distance traveling main scale by main scale called, for what? For one complete circulation of circular scale. For one complete circulation of circular scale. Okay, understood? Just start from 0. Again you are rotating and come to this 0 circular scale. Your one complete rotation is complete. Now is moving, for example 0.5 millimeter, the main scale reading will be 0.5 millimeter. Is traveling a distance or moving a distance 1 millimeter, then it will be 1 millimeter. So pitch is the distance traveled by the main scale for one complete rotation of circle. Okay, pitch is the distance traveled by the main scale for one circulation of circular. Clear? So least count is pitch of the screw, called pitch of the screw. What is pitch? The distance moved by the screw along the axis in one complete. এবার তো নোটস গুলোকে ভালো বানাতে হবে, বাড়িতে নিজেকে পড়তে হবে না, এবার বাড়িতে পড়তে হবে তো। এই তো এই লিখছি, দেখো তোমার সাথে প্যারালালি লিখছি, ওদিকেও লিখছে, নোটস খুব কত টাইম পাবে? তাহলে টোটাল নাম্বার অফ ডিভিশন, what is pitch? Sorry, least count, the pitch of the screw divided by total number of circulation. If the circular division, total number of division in circular screw, it is 50, then we will divide it by 50. One pitch divided by 50, it is 100, we will divide it by 100. It is 200, we will divide it by 200. So if, for example, let us assume the pitch equals to 0.5. Okay, total number of division circular scale, total circular scale division equals to 50. What will be the pitch or least count? 0.5 divided by 50 equals to 0.001. করে দেখো 0.0. Some cases your main scale division to main scale division one millimeter, could be 1 millimeter. Circular scale division could be 100, could be 100. So in this case again least count comes what? 1 millimeter divided by 100. If it is 200, then it is 1 millimeter divided by 200 is equal to 0.005, right? Which is no, this pitch could be different for different. For this one, this could be 1. There are now 25 number of division could be there. For a better one or more precision making, 100 could be 200 for some other cases. Circular division is very fine, 200 numbers of division, right? Again, zero error, right? There could be zero error, positive zero error and negative zero error. দুটোই দেখিয়েছি এখানে positive zero error. In case of positive zero error, your circular scale division will be below the what? Axis. Below the axis. So your circular scale division will be below the axis, and you can clearly see the main scale, zero of main scale. You can clearly see the zero of main scale for positive zero error. In case of negative error, will not going to be zero of main, okay, and in case the zero of circular scale will be above the, if this is line is axis or central line, you can say also, if this is central line, the zero will be above the central line or axis. So how many lines? You can say 5 lines. You can say this 95 is coinciding with your axis. Above 95 it is 5. So your division will be, circular division will be 5. Or other hand, you can write circular scale division or equals to 100 minus 5. You can also write 100 minus 95. Your reading is here 95. Will take 100 minus 5 for 0. But in this case, it is 5. It is coinciding with 5 or 6. 5 or 6. So it is, you can say, sorry, it is division is 6. Circular scale division here 6. In this case, we will take 100 minus 90 because it's above, and 95 is actually coinciding with this. If this scale shows you 50 division, and if it is 48, coinciding is 48, then we'll take 50 minus 48. Okay, এখানে কত থাকতে পারে? 50 number of division থাকতে পারে, and your 48 actually coinciding with circular scale, sorry, main scale or axis, right? Your 48 division can coincide with main scale, right, or axis. Then we'll take 50 minus 48. As this is negative zero error, we will take negative front. As this is negative zero error, you will always take negative. Multiply by your so circular scale or reading, sorry, zero error here equals to circular scale division, right? So we will put plus here circular plus zero error. So here minus, right? This, and you will put the value with sign, right? When you finally measure thing, you put the value with sign. Okay? So your observed reading will be with sign. If it is positive, you will put the value positive, negative within bracket. Okay, within bracket you will put the value and then you see. Okay, problem করা যাক। এখন বোঝা যাচ্ছে? Do you have any problem with Bengali language? আর কারো কিছু আনসার? কারো? শর্মিষ্ঠা? হয়নি? করো করো। ঘোষ? দত্তা? স্লো হয়ে গেলে কি করে হবে? পিচ কি কি বলে দিয়েছে দেখা যাক। ফার্স্ট করতে করো। হয়েছে? কেন গুলাচ্ছে কেন? কোথাও পড়ার বুঝতে কোথাও মনে হচ্ছে যে কনফিউজ করে পড়াচ্ছি এরকম কিছু? লাইন বাই লাইন পড়াচ্ছি না এরকম গ্যাপ? ফার্স্ট অফ অল পিচ কি বলে দিয়েছে? 0.5 circular scale. So the pitch and the number of division on the circular scale for a given screw gauge are these. Pitch বলে দিয়েছে, তাই তো? Pitch বলে দিয়েছে 0.5 মিলিমিটার। নাম্বার অফ সার্কুলার ডিভিশন ইন সার্কুলার স্কেল বলে দিয়েছে 100, তাই তো? তার টোটাল সার্কুলার স্কেল ডিভিশন equals to what? 100. Can we take least count? Can we? Pitch divided by 100. millimeter, correct? Now this part is শেষ হয়ে গেল। When the screw gauge is fully tightened without any object, এটা কার জন্য করব? জিরো এরর আছে কি নেই তার জন্য করব, am I correct? উইদাউট ইনস্ট্রুমেন্ট মানে উইদাউট অবজেক্ট আমরা কখন করব? we'll find the zero error if there is any zero error or not. Now the zero of its circular scale lies 3 division below. 3 division below means positive zero or negative zero error? Positive zero error, excellent. 3 division, so 3 division means how much? So zero error, তো পজিটিভ জিরো এরর হলে কি বলেছিলাম, পজিটিভ রেখে দেবো, শুধুমাত্র কি নেব, নাম্বার অফ ডিভিশন ইন্টু মাল্টিপ্লাই বাই লিস্ট কাউন্ট 3 ইন্টু 0.005 equals to 0.015 millimeter হয়ে গেছে আমার জিরো এরর। নাও the reading of the main scale and the circular scale for a thin sheet, right? Ever you introduced a thin sheet, now your circular and main scale reading. So main scale reading 5.5 millimeter. What is your circular scale division? Circular scale reading means it always indicates circular scale. Circular scale reading always indicates circular scale division. So circular scale division equals to 48. Can we calculate circular scale reading? 48, list count 48 in 0.00. 0.024. Zero to 4 no? Oh, 5 to multiply to, sorry. Right? Okay. Now, what is reading? Main scale reading plus circular scale reading minus নেগেটিভও দিতে পারতো, হয়ে গেল জিরো এরর। ডিভিশন বিলো না হয়ে এটা কি হতো, অ্যাভাব থাকতে পারতো, তাহলে এটা কি করতাম, জিরোটাকে মাইনাস অফ মাইনাস জিরো এরর করতাম, তাই না? অ্যাভাব থাকলে কি হতো, মাইনাস অফ মাইনাস জিরো এরর, তাহলে এটা কি হয়েছিল, প্লাস হয়ে যেত, প্লাস হয়ে যেত, রাইট? কোশ্চেন থাকলে বলো, কোশ্চেন নেই আজকে? পজিটিভ জিরো এরর, নেগেটিভ জিরো এরর। পজিটিভ জিরো এরর যখন থাকবে তখন দেখবে উই ক্যান ক্লিয়ারলি সি দ্য জিরো অফ মেন স্কেল। এখানে দেখতে পাচ্ছ জিরো অফ মেন স্কেল দেখতে পাচ্ছ, এখানে জিরো অফ মেন স্কেল দেখতে পাচ্ছি না, এটা থেকে বুঝতে পারছি এটা নেগেটিভ জিরো এরর, দিস ইজ পজিটিভ। আর একটা কি বোঝার উপায়, below the circular scale must be below the central line or axis. This is axis or central line. What is zero? Zero is below the central line, then it is also positive zero. যখন তোমাকে প্রবলেম সলভ করতে দেবে তখন তার ওই ফিগার দিয়ে দেবে না, না, তখন কি বলবে, বিলো দ্য সার্কুলার স্কেল অর অ্যাবভ দ্য সার্কুলার স্কেল। তাহলে বিলো দ্য সার্কুলার স্কেল হলে কি হবে, পজিটিভ জিরো এরর, অ্যাবভ দ্য সার্কুলার স্কেল হলে কি হবে। এবার তুমি রিডিং থেকে ডিরেক্টলি করতে পারো, তাহলে এখানে রিডিং কত আছে পজিটিভ জিরো এররে, 5 or 6, আমি বললাম 6, তাহলে কি হবে 6 ডিভিশন ইনটু লিস্ট কাউন্ট। এর জন্য আমি কি করব, 95 রিডিং নিতে পারছি, 95 তো জিরো এরর নয়, কতগুলো ডিভিশন উপরে আছে? 5 ডিভিশন। তাহলে আইদার তুমি 5 যতগুলো ডিভিশন উপরে আছে সেটা নিতে পারো, অথবা ম্যাক্সিমামের থেকে কি করতে পারো, তোমার রিডিংটাকে, বাট ফ্রন্টে যেহেতু নেগেটিভ এরর, তো ওটা ফ্রন্ট অফ। ম্যাক্সিমাম কত ডিভিশন আছে? 100। এখানে রিডিং কত দেখাচ্ছে? 95, রাইট? তো 100 মাইনাস 95, আর করো। নেক্সট আমরা শুধু এই চ্যাপ্টারের যতগুলো প্রবলেম আছে একটু প্রবলেমস করব বলতে। হ্যাঁ, বলো।